Thanks. He always is always caught up by questions following his speech. So moving on to the next one. We're running a bit late, so let's just speed up. Professor Jun Lee from Cutting You.
Yeah, thank you, Lei, for the introduction. Uh, Thank you. Yeah, my name is Junli from Curtin University. So today I would like to talk about using generative AI techniques for structural health modeling. So recently you have many discussions, especially also last night we also talk about generative AI. So first of all, I would like to acknowledge our team, collaborators, research fellows, and former and current PhD students, and also some ARC research grant support. As we all know, as many researchers today mentioned, the importance of doing structure monitoring and the maintenance, and it's so important for our society. And in this area, Yang also mentioned that data quality is important. Yes, that is absolutely true. And also the data, when we use those data for structural health monitoring, the data imbalance and the insufficiency is also a challenge. For example, we don't have so many data on the extreme events from structural health modeling, and those insufficiency may lead some challenges to us. This is an example. We collaborate with Manos, Western Australia, on monitoring a highway bridge in Rockingham. So as you can see, limited sensors are installed on several typical sections of this bridge to monitor the half joint connections. And also, we only connect the data on the some triggered heavy loading events. So that means we have limited number of sensors and limited data for the analysis. So traditionally, we also use we develop vision and AI techniques for structural health monitoring. So recently, we use cameras to measure structure displacement. So we analyze the images, identify the key figures from those images, and track those key figures to get the displacement. And then that is some advantages, some using vision-based methods. And we work on target-free methods. That means we don't need to install any artificial targets on structures. We use the later figures from structures as key points so as we can track multiple locations on the structures to identify the vibration displacement so that we hope this is a relative efficient solution to replace the traditional vibration sensors, for example, accelerometers. Summarize these challenges on vibration-based structural health modeling. I mentioned the data imbalance and the data insufficiency. Here, in this talk today, we try to use generative AI techniques to synchronize, generate some synthetic data. So that is also a data augmentation techniques we use to generate some responses for our studies. So I will present some applications later on. And on the vision-based displacement measurement, so some traditional challenges, for example, lighting, target-free lighting conditions. So that's not the main focus of today. Today, I talk about insufficient data. For example, when we try to use cameras to measure three-dimensional data, the training data is limited, especially in the depth dimension. So that means we could not have that many data, training data, for measuring the three-dimensional displacement cases. Yesterday, I tried to use ChatGPT to generate some images for today's presentation. So left side is a Chinese style interior room style. I put in the ChatGPT, so you will see it's quite good, right? but something I could not even see because they're supposed to be Chinese characters, but I could not recognize that. So that means it looks like it's a Chinese room, but some elements might not be that right. So that means for our structure applications, we also need to be careful about the physics behind this. So that then I used another props like cracks on load payment. You can see that is a generated image by ChatGPT. Looks quite good, but up to you and engineers to decide whether this is realistic or whether this is meaningful. And I also generate some images for some complicated scenarios. For example, I used the minor cracks on concrete bridge subject to heavy vehicles. Then generate something like that. It may not that be realistic, but you can see some cracks over there, and also some cracks on the road, right? So that is interesting. And also, I also generate a video. So I only used the 2 images. This is a report on a bridge vibration due to vortex in China. So that is a news report. So I just used the 2 images. This is a car moving across the bridge. So that here it's stop here. So the bridge is actually vibrating from the original video. And this is an overview of the bridge. So I use these 2 images to generate a video. So can you help me to play that one? Oh, I can do that. So just use 2 images. You can see quite good. It looks like a newspaper report or some TV report. So that is something using 2 images can generate a video. So then I used our test video. So we did some vibration testing on a cantilever beam. So underneath that is a shake table. I just cut because due to the software limitation, I can use only portion of the images or video. So I only use 2 images here. So that is vibrating. So you can see at a different location. This is original. This is a little bit vibration there and deformation. And I use these 2 images to generate a vibration video. It's quite slow because I tried a different command here, pop scale, but just this one, you can with bring it vibrating with a harmonic frequency. You can see a little bit vibration there. So that is something I try to explore. So to explain the idea of generative AI. So I used this for some applications. The first one is to generate some data for model identification and the lost data recovery. So the first issue is if we talk about the imbalances. So the first issue is major data on the normal state. So we have majority data is on the normal excitations, but very minor data on the extreme events. So that means the data is imbalanced and insufficient. And the insufficient means, for example, some data lost because these represent typhoon events. And initially, some sensors, all the sensors are working well, but after certain period, the sensor is not working, so we lost that part of data. So that is methodology. I probably don't talk about too much about the details. This is a diffusion model we used to generate the data. So compared with previous studies, by using generative GAN and also network, so it's a GAN network, we use diffusion model. It's more powerful, and it can be used to real large-scale structures than laboratory-scale structures. And it can generate multiple channel data as well. So you can see this is a Guangzhou TV tower data. We use only 1 day data to train the network. So we use the short axis accelerometers. And once we trained this diffusion model, we can generate an example of data. So this is a generated data for those sensors. So we use those generated data to identify the mode shifts and the natural frequency. So when we compare the results, you can see those results are very consistent with the true data. So almost give you the exact same natural frequency and the mode shifts. So that means those generated data, they also contain the physics information of the structures, for example, the vibration properties. And then I further use this for a scenario to recover the lost data under a typhoon event. So this is a simulated case. For example, we use the real data from hurricane. This is practical, but for some channels, we just assume some data are lost, right? So we use this part as a training data. So that means for those part, we have all the sensor data. The sensors are functioning well. So we got this part of data for training. And we for this part, the data is lost. So we try to recover this part of data. Yeah, so that is our recovered results. We can recover or generate those vibration data for those sensors. We assume they are not working properly during the typhoon event, and you can see we can see they also match the original ground truth data very well, not only in the time domain but also in the frequency domain. Then the error is also quite good. So the next case is we use 3D generative AI framework for vibration displacement and measurement. So this is a further improvement based on our previous studies on using vision-based methods to measure three-dimensional displacement. So the challenge is to measure the depth direction displacement. So we use advanced generative AI techniques to generate some synthetic images and videos for training the network. And that is also based on some physics. For example, if we have a finite element model, we can, based on the finite element model or even analytical solutions for cantilever beam or simply supported beam, we can have the deformation shapes of a cantilever beam or of a simply supported beam. Based on this, we can generate some synthetic data. And also we use text to image diffusion model. So that means we just need to describe what you want. For example, we use ChatGPT to generate some descriptions about astronaut. And the ChatGPT said, a photography of an astronaut riding a horse. Then you get an image like this. So that is something interesting. So we can also use that in civil engineering applications. If you want to generate a beam, a timber beam or a concrete structure beam with some textures, yeah, we use the diffusion model and to generate this texture, the mesh for these beam structures. So that is some promote generator from ChatGPT. For example, you can see this is for a timber beam structure. This is for steel beams, for concrete beam, for cracked concrete beam. So you can see some different generated structures on this. And that is some synthetic data we obtained with some deformation, right? So we use this for some application. For example, we can do the three-dimensional reconstruction. So you can see this is a vibration beam we do in the structure. It's cantilever timber beam, and we do the segmentation map and depth map, and we can obtain the three-dimensional point cloud. So you can use this as a digital twin or further applications. Or we can use that for vibration displacement measurement. At the same time, as I mentioned, we include the analytical solutions of the deformation of the structure in the network, in the generation of this data set. So to make sure this make a little bit more sense on the deformation of the structures, it's also important to include the physics in the AI. So that is the deformation for simply supported beam or cantilever beam. And those are some our generated deformations and the structures. So we used this for three-dimensional displacement. So I don't go to the details of these methods, but we use network to track. This is a track anything model. We can use these methods to track any objects you identified in the video or images. So that is our experimental setup. We set up a camera by using an iPhone 14 Pro camera. And also some laser displacement at ground truth. So we compare with the results. So that is some generated data. We applied it before there, and then we got the displacement generated synthetic data, and also videos. That is the results. So the green line is the vibration displacement we obtained from the vision methods, and the dashed line is the ground truth. So you can see they matched very well, and also the cross correlation is very high, almost 0.98. Relative error is quite small, and also the vibration frequency matches very well. So that means the data are accurately measured by these methods. So that comes to the conclusion of my talk. So maybe using generative AI is a debatable topic now. So now I try to explore using this for structural health modeling and present several applications. So last is responsible use of AI techniques and be cautious of physics behind that. So that is my talk. And thank you very much for your attention. And I would like to answer any questions.
I think if no more questions, we do not take any questions because of the time constraint. So let's move